Okay, for this last bit of notes on slope, we're going to be focusing on the back side of the notes. We are going to flip back to the front in a minute, but a lot of what we're going to talk about right now is on the back. So when you have an equation of a line, it takes the form of y equals mx plus b, meaning y is isolated, it's all by itself. Then we have our equal sign, our x term, and then we have that constant. Okay, and I put little reminder bubbles down here of what each of those are. So first of all, y does have to be isolated, like we talked about. The m, that number that is right in front of the x, that is the slope. So if y is all by itself, whatever number sits in front of the x, that is our slope. Okay, and then finally, the b, that constant, is the y-intercept. And that's where the line is going to cross the y-axis. And we'll get into that more later. But really what we're going to focus on today is just identifying that slope. Okay, so I have a couple of pretty straightforward examples here. But remember, our first goal is always to get that first cloud there, that the y is isolated. So if you look at number one, the y is isolated, so all you have to do is read the slope. So the slope is the number right in front of the x. So in our case, slope is a -3. Let's look at number two. Y is isolated again. Y is all by itself. So the hard work is done. I just need to look at that number in front of the x. So this time my slope is 6. Okay, you take a second, look at number 3. The y is isolated. Think about what your slope is going to be. Okay, so because y is isolated, the number in front of the x is 1/2, so my slope is 1/2. All right, now, unfortunately, life isn't always that pretty. Okay, it doesn't always work out nice and neat for us. Okay, sometimes we have to work a little bit to get y all by itself, and this is part of the reason we do boot camp. It's part of the reason we did solving formulas, because really we're solving every one of these formulas for y so that we can read our slope. Okay, so let's look at number 4. Let's look at number 4 here. Number 4 says 2y equals 4x minus 6. I'm going to zoom in just a little bit more. You can see that a little bit better. There we go. All right, so we have 2y equals 4x minus 6. Now, the y term is all by itself, but I need to get rid of that 2. I have 2 times y, so in order to undo the multiplication 2, I need to divide it by 2. Now, here's the tricky part. You have to divide every single term by 2. I want you to write it like that. I want you to write it where divided by 2, divided by 2, divided by 2, divided by 2. I absolutely, 100% do not ever want to see this. Okay? I don't want you to see you're dividing the whole side by 2 right now because you're terrible at making sure that you understand that each of those terms are being divided by 2. Because I'm dividing everything by 2. So I have y equals. Now I can simplify. What is 4 divided by 2? Well, that's 2, and I still have my x, minus 6 divided by 2 is 3. Okay, so my y is isolated now, it's all by itself, so my slope, again, it's going to be that number in front of the x, my slope is 2. Okay, let's look at number 5. If x plus y equals 7. Okay, x plus y equals 7. So I need to get y here all by itself. So that means I need to get rid of x. Right now that's a positive x, so I need to subtract that x away. So I have y equals, I have a negative x plus 7. Now you could put 7 minus x, but remember proper form when you're doing algebra, like the grammar of it all, is our variables come first and our constants come at the end. So that's why I try to do that. And plus it's in our form for lines. Okay, it's in that slope, it's called slope-intercept form. So now, y is by itself, so I need to look at that number in front of the x. Well, I just have a negative, but what number really sits there? Really a -1. So our slope in this case is a -1. Let's take a look at 6. Take a look at 6 here. We have -3x plus y equals 9. Again, our goal is to get y by itself. So I need to get rid of this negative 3x. So in order to undo the subtraction of 3x, I need to add 3x to both sides. So I have y equals, again, thinking about the grammar, about the proper form, 3x plus 9. So if y is by itself, what's our slope? The number with the x, so it's 3. Our slope is 3. Okay, let's do 3 more examples here. Okay, number 7. Remember, our goal is to get y by itself. So the first thing I have to do is get rid of the 2x. So I'm going to subtract 2x from both sides. So I have negative 4y equals negative 2x plus 8. Okay, now, y is still really not by itself. Now, it's isolated as far as it's all on the left-hand side there, right? But I need to get rid of that negative 4. So I need to undo that multiplication, which means I'm going to divide every single term by negative 4. Remember, every single term by negative 4. All right, so negative 4 divided by negative 4, that's just 1. So I have y equals negative 2 divided by negative 4. That is, think about that, negative divided by negative is a positive. 2/4, same thing as 1/2 x. And then 8 divided by negative 4 gives me a negative 2. So my slope in this case, y is all by itself, y is isolated. So the number in front of the x is my slope. So my slope is 1/2. Okay, on the next one here, I think I have a typo. This should be negative 5x minus y equals 8. So make sure you make that an equals 8. Try to make that look right. Equals 8. So make sure you fix that. Okay, so again, our goal is to get y by itself. I need to isolate that y term first. So I have a negative 5x, which means I need to add 5x to both sides. So I have negative y equals a positive 5x plus 8. Okay, this is another one of those, we do have y by itself, but there's a negative in front of it, so you got to really think about what number that is. That's really a negative 1. So I need to divide every single term by negative 1. So I end up with y equals negative 5x minus 8. So my slope here, because y is isolated, the number in front of the x, that coefficient is negative 5. So my slope is a negative 5. Okay, last one. Last one. So this one says 2x plus 2y minus 8 equals 0. Okay, so I want to get y by itself. So first thing I want to get rid of, let's get rid of that negative 8. Let's add 8 to both sides. So I still have a 2x and a 2y plus 2y equals a positive 8. And I need to get 2y all by itself. Try to get the x term to the right-hand side. So that means I'm going to need to subtract 2x. So I have 2y equals negative 2x plus 8. Okay, now it's isolated, but I still got to get y by itself because it's really a 2y. So I need to get rid of that 2. So 2 times y, I need to undo that. So we're going to divide by 2. Don't forget we're dividing every single term by 2. So I have y equals negative 2 divided by 2 is a negative x. You could write negative 1x or you could write negative x. Both are correct. And then 8 divided by 2 is 4, so I have plus 4. Okay, y is isolated. So the slope is the coefficient in front of that x, so we have a negative 1. All right, so our main focus here, we have 2 parts. First, we're trying to make sure y was by itself. We isolated the y, And then once y was isolated, we were able to write our equations. We were able to rewrite our equations, and then we were able to identify our slopes. Okay, now, I want you to flip your paper back over, flip your notes back over, because we left some boxes empty up here. We wanted examples of equation examples here. So let's think about that positive slope. Let's think about positive slope. Think about a positive slope and equations. So keep in mind, we just did a whole bunch of y equals. So y equals, and we need that number in front of the x to be positive. So it could be 3x minus 6. Y equals 2x minus, well, it could be plus 1. Okay, anything where you have y equals, and then that number in front of the x is a positive number, that's going to have a positive slope. Same thing with negative numbers. Same thing with negative slopes. We need negative numbers for our slopes. Okay, so I could have y equals negative 7x plus 1. Y equals a negative 4x minus 2. So as long as that number in front of our slope, in front of our x is negative, that's going to have a negative slope. Again, my y is isolated though, so make sure you have that. All right, now, the last two are a little bit different. The last two are different. If we have horizontal and vertical lines, okay, what happens with these is these do not have, they're missing a variable. Okay, it's just one variable equals a constant number. When you have a horizontal line, it's always just y equals a number. So this one might be like y equals a negative 3. Or it could be y equals 2. Or y equals 7. Okay, so if y just equals a constant, notice there is no x variable. That's because it doesn't matter what x is. Y is forever, ever, ever always going to be that value. So in this case, when you're dealing at y equals negative 3, that might be a pretty good estimate for the graph I have drawn here. It doesn't matter where we travel on the x-axis, y is always negative 3. Now with vertical lines, it's your other variable. So it's going to be like x equals 2, or x equals negative 5, or x equals 10. Okay? Again, y is not a factor in this. Why does it matter? Because x always has to be 2. It doesn't matter where we travel up and down that line, x is always going to remain 2. I think this is the hardest thing for people to think about. These two here are the ones that people mix up the most. Okay? You can use logic to figure out which one's which. There's a little bit of a trick too. Let me clear some space here. Well, no, this will work. All right, so think about H for horizontal. H for a horizontal line. Look what happens if I take that H and I turn it upside down. It looks like a Y, so it's a Y equals a number. Okay, now think about the vertical lines. Okay, vertical lines, it's x equals a number, but if you think about it, the x is made up of a whole bunch of little v's right here. So those are vertical lines, x. It's a silly trick, but if you can't logic your way through, you can't reason your way through, maybe that'll help you figure out horizontal versus vertical, whether it's x equals a number or y equals a number. All right. So after we're done with the notes here, you're going to be doing another activity in Classroom. Okay, going back to Google Classroom, and I want to show you what it looked like. There are two parts. There's actually 4 different slides here. You can see there's going to be 4 different ones you're going to work on. The first 2 are similar, and the last 2 are similar. On the first 2, on the left-hand side, you have an equation where you're just going to solve for y. Okay, you have an equation where you're just going to solve for y. So we would, in this case, for instance, have to subtract an x and then divide by -1. So wherever you think the answer is, you're literally just going to take the end of the arrow, and take the end of the arrow, and you are going to drag it to whatever equation you think that it belongs to. So let's say I think it belongs to this one. Oops, sorry. All right, so that's not working. I'll fix the arrows, but you're just going to drag it over. So it would be like, if I had an arrow,
If you wanted to match it up with this one, then you're going to draw it like this. So I will fix that to make sure it works. So it's just a matching like that. Okay, so there's 2 of them like that. The next one then, you have a whole bunch of equations down here. We're going to list these slopes in order from least or smallest to the greatest. Okay, so for instance, like you can see like the slope on this first one is 2. And the slope on this second one is -7. So when I go to order these, -7 is going to be smaller than 2. So I'd want -7 down here on the left somewhere, 2 on the right. And you're going to go through and deal with each one of those. Okay, and you're just going to drop and drag them, or drag and drop them into their proper order. Same thing with this page. When you're done with that assignment, make sure you turn it back into me so I can go back through and check it as well.